All right, let's have a look now. Let's move on to cube root. And we're asked to find what is the cube root of the number 8. So the idea is going to be the same, guys. Take a look. Notice that the index has been changed. So again, it's the same idea. You need to find a number x that you raise to the third power cube, and then you get 8. What is the number? What is that number x?
2.
Okay, correct. So that number 8 has to be 2. Why 2? Because 2 times 2 times 2 is going to be 8. 2 cubed, guys, is the same as 2 times 2 times 2, 3 times. And that, which is equals to 8. So the cube root of 8 is 2. Correct. Do I have to do that in every single step? No, I'm just showing you guys the relationship between radicals and exponents. Take a look at a radical, guys. A radical expression, guys, is just the opposite. It's just a reciprocal operation of exponents. So this is. So let's have a look at another one. Okay, we got square root of one cube root, sorry, of 125. And again, the idea is to simplify this. So you need to think about a number, guys, that you multiply it 3 times thrice, and you get 125. So 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4, 16, 16 times 4, I think it is 64, 5 times 5, 25, times 5, 125. So as someone said, that number is 5, guys. The cube root of 125 is 5. Because why? Why 5? 5 times 5 times 5, you're going to get is 125. So 5 is the cube root of 125. This is so easy. This one. What is the cube root of 100,000?
Is 10.
10.
And
That is correct. That's going to be 10. Why 10? Why 10? Because 10 times 10 times 10 is 1,000. So that's why the cube root of 1,000 is just 10. This is so straightforward. Let's try a tricky one. So you can pause this video, guys, and try to find a number you multiply three times itself, and you get 16. You're going to realize that's not possible at all. So in cases like this, the only option that we have is to use prime factorization. Okay, let's break this number down, 16. So we're going to break it down, 16, and we're going to see what is going to happen. So again, we're going to use a prime factorization. Let's start off with number 2. What is a half of 16?
8.
Correct. What is a half of 8?
4.
4.
Thank you. What is a half of 4?
2.
2.
All righty. What is a half of 2?
1.
1.
1. You are correct. So what are we going to do, guys? In comparison to the square root, guys, we used to group two terms. In this case, guys, just look at the index. The index is 3. So you're going to make group of 3. Just as simple as that, okay? 1, 2, 3. Okay, this is one group. And this is the leftover part. Again, you leave it like that. So instead of having 2 times 2 times 2, guys, I need to rewrite that as a exponential expression. 2 to what power?
Cube.
To the third power, 2 cube, right? Because you're repeating 3 times. 2, 2, 2 is 2 cube. Okay? And this 2 is the leftover part. You leave it like that. Now let's rewrite this. Cube root of 16, a cube. And then let's rewrite this. 2 cube times 2. Okay, let's put 2 cube, 2 cube times this 2 that is alone, the leftover part. I repeat, this 2 cube and this 2 cube times 2. If you don't think this is the same, 2 cube is 8. 8 times 2 is 16. It's the same. I'm just rewriting, guys. I'm taking advantage of the properties. So is there any property I can use here, guys? On my edge?
We
If
can
you have the
cancel
same,
that 2 cube.
correct, index and the same exponent, guys, automatically you take that out It's just the same, 2. And this is going to be inside the square root of 2 cube. Okay, the 2 remains inside, and this blue one, it remains inside because this is exponent 1, this is exponent 3. Okay, you can't cancel that. Okay, and this is the simplifying form of cube root of 16, 2 cube root of 2. Again, we're given a cube root, which is not a perfect one. So we can't find a number multiplying it 3 times itself and get 500. So again, we're going to use the prime factorization, which is the only solution we have here. So let's copy 500 here. And let's break it down again. So we'll start off with using the first prime number 2. What is a half of 2? Of 500?
250.
250, thank you. What is the half of 250?
125.
125, that's correct. What is the half of 125?
It doesn't have.
It doesn't have, this is not an even number, guys. You only look at the last term, digit, and you have to know if it is 2, 4, 6, 8, and 0, it's an even number, which means you can get a half of it. But if it is different, so if it is an odd number, it's not going to have. So this number doesn't have third part, I think, or does it have it?
No.
No, right? So does this number have fifth part?
Yes.
Yes.
Okay, fifth part. And what is the fifth part of 125?
25.
25, correct. And 25, what is the fifth part of 25? 5 times can you get 25?
5.
5.
And what is the fifth part of 5?
1.
1.
5 is 1 here. Okay, correct. And we just break it down. We just broke it down. So now, guys, again, look at the index and make group of according to this index. It's cube. Okay, you're gonna make group of 3, guys, with the same number. So with the same number. Take a look that I only have 2 2s, guys. I cannot make a group. But here, guys, I have 3 5s, right? 5, 5, and 5, guys. And instead of having that, I'm gonna have 5 to what power?
The third power.
Third power, 5 cubed. And this leftover power, guys, since this is sobrante, leftover power, guys, 2 guys, you can multiply because this is factoring, right? Factoring means representing something as a multiplication. All these terms are multiplying each other. 2 times 2, guys, is what?
4. 4.
Okay, this would be 4. So just like that, 4. This is what we do with the leftover power. So again, let's rewrite this. This is the cube power. So instead of 500, I have 4 5 cube. Okay, let's put that 4. Okay, I'm gonna put actually that what I'm gonna cancel, guys. 5 cube times 4 is the same. So let's rewrite this. So guys, can I do something here? I have 5 cube and cube root of that.
You can cancel.
I can cancel this because I have the same one, right? And cube root of 4, guys, I just copy it. Okay, cube root of 4. Okay, cube root of 4. And this is going to be the final answer. Look. Let's go look at this. We are asked to find a number that will multiply 3 times itself and we get 8, but negative form of 8. So negative version of 8. So let's find that. Okay, again, I need to get negative 8. What number do we multiply 3 times and get 8, guys?
2.
2 times 2 times 2, right? So if I leave positive, because I can use positive, but all of them positive. I cannot say this positive and this negative. No, guys, because what's going to be the answer then? Minus, positive minus. No. Okay, what am I going to do, guys? I'm going to have this. I'm going to try with positive. Positive, positive, positive. Okay, positive times positive. Positive, right? And another positive is positive. No, guys. So it is not positive. But 2 times 2 times 2 is 8, guys. So now let's try with negative. Negative 2, and negative. Let's try the negative version of 2. Negative and negative, what I get?
Positive.
Here I get positive. Times negative.
Negative.
Negative. Oh, yes, -8, which is exactly what I'm looking for, guys. Take a look. In this case, we're not going to need, guys, the complex number. So because the cube root of negative number do exist. Have that in mind. They do exist. Okay, what is the square root of the cube root of -8? Negative?
Negative.
-2. Correct. Take a look. We don't need the I expression, okay? Why -2, mister? Because -2 times -2 times -2 is -8. 2 times 2 times 2 is 8. Negative, negative, positive times negative is negative. Okay, let's move on. Got it. Let's have a look at this one. Okay, what is the cube root of -64? Again, we know that the cube root of negative number do exist. So what number do we multiply 3 times and get 64, guys?
4.
-4.
4 times 4 times 4. Okay, which sign should I use? Negative, negative, and negative, positive. And negative again, I get the negative. Okay, that is -4. So we don't need the I or the complex number, imaginary numbers.